Hey everyone, John with the GSSI training team here to demonstrate how Geolitix's cloud-based GPR processing software allows you to efficiently complete structural analysis jobs and create high-quality deliverables for your clients. I'll be working with a 3D dataset collected on a rebar-reinforced test slab at our Nashua, New Hampshire headquarters. I'm going to assess the data like a typical structural analysis job by locating the rebar, exporting the bar locations and calculating bar spacing, and creating a rebar depth of cover map. I'll start by importing my files into Geolitix. I'll make two folders, one for the X direction lines and one for the Y direction lines. That allows me to properly position each set of transects and process and analyze them separately if necessary. Next, I'll position the files in my 3D grid, setting the line order and spacing for the X and Y direction lines. I'm going to use the normal pattern for both sets because all of my lines were collected in the same direction, and I'll enter the correct line separation of 5 inches. I'll then select the left direction, meaning subsequent lines should add to the left of previous ones when looking at them in the direction of travel, and rotate the X direction lines 90 degrees so that they properly run left to right. The default orientation with no rotation is bottom to top. For the Y lines, subsequent lines should be added to the right of previous lines, and no rotation is needed because I do want them running from bottom to top. For a more detailed explanation of these steps, head to the Geolitix webpage titled Positioning Non-GPS Projects. Next, I'll go to the Process tab. Once I have a 2D profile opened, I can process the data. I'm going to click on the 3 dots and select Suggest Processing and have Geolitix suggest processing steps for discrete targets. There are a ton of processes you can apply manually, but the suggested processing looked fine for my purposes. Next, I'm going to pick the rebar, placing dots on each rebar reflection so I can export the depths and locations of each bar within our grid. I'll start by using the Auto Discover tool. This will attempt to auto-detect hyperbolas within a specified window and place a pick at the peak of each one. Hovering over my 2D data, you can see that the rebar in this profile is about 2 nanoseconds deep. We'll set our minimum time to 1.5 nanoseconds and our maximum time to 3 nanoseconds. I'll also increase the threshold a bit. This will make Geolitix pick more targets, even if they are weaker signals. I'll hit confirm, and then I'll go through each file and manually edit the points, removing erroneous picks and adding picks to rebar that the automatic picking function missed. Once I've picked all the rebar, I can add a depth grid layer to my project. I'll select my point interpretation layer and then have Geolitix suggest parameters for the depth grid's interpolation. Then I'll hit process to create the grid. I can also go to the options menu on the left to customize the color scheme for my depth grid. Once it looks the way I want, I'm ready to export the depth grid and pick locations. First, let's export the depth grid. I'll hit Export at the top of the UI and select PNG, which is a common image format. Then, I'll select either Current View or Depth Grid and hit Export. Geolitix will then download the depth grid to my hard drive. Here's a look at the final depth grid. Next, I'll export the bar locations. This time, I'll select CSV format so that I can open the data in Excel, and I'll export the point interpretation. I can open the downloaded file in Excel and easily calculate the average bar spacing along each profile. Thanks for taking the time to learn about Geolitix's cloud-based GPR processing software and how it can help you process your GSSI GPR data for structural analysis jobs and create customized visuals without the need for additional plotting software. Reach out to sales@geophysical.com for a quote for Geolitix or GPR equipment, and leave any questions that you have in the comments.